Hello? Sorry, just this thing. Can everyone hear me, guys?
Yes, we can.
Oh, that's cool. All right, I'm just trying to log on, make sure my AirPods are working. All right. Missed the introduction. You gave a brief introduction already. So yeah, I think I just very quickly I want to ask a question to you guys, and I want you guys just to let me know what you think about what do you know about artificial intelligence so far? Because that's a talk I'm supposed to give. So, what does anyone know about artificial intelligence so far? Question goes out to Melinda.
I think artificial intelligence is like using more like using softwares in companies to do most of the work. Yeah.
Okay. Okay. Now, I want to ask all of you guys, because you're a different generation from a lot of the people I deal with. How many of you think artificial intelligence will replace engineers in the future? Just raise your hand if you say yes. Don't do anything if you say no. Okay, that's about 30. So, do you think that you won't have any more jobs if artificial intelligence is really good? Or there's still a role for engineers? Anyone raise your hand and actually answer that? Uh, Those I know, okay. Alia, well, unmute your mic and answer that. Any one of you think engineers will get replaced? Hello? Okay, I guess it's not Alia. All right, then it's on to, let's see, Ping Jun. Do you think engineers will get replaced?
I don't think engineer will be replaced because engineer is very important in our industry. Yeah.
Okay. All right, so I'm just gonna start my presentation about VROC. You probably know a little bit about me already. I think Melinda, you gave a brief introduction. Anything you mentioned that wasn't on my bio? No, no, right? Hello.
I know, so I only mentioned that you're the CEO of VROC South East Asia.
Okay, I'm the CEO of VROC. Okay, so I'll start and do a quick preso with you guys for about 30 to 40 minutes. I won't make it boring, so hopefully we can interrupt it for Q&A. Now, I think the first question people want to know is how do you pronounce VROC? It's actually VROC, not VROC or VROC. Now, the question we all get asked is what does VROC stand for? So it's Virtual Reliability Optimization Control. Because a lot of engineers, right, they want to think of something totally different to give it a name or make the name really complicated. My name is Juarez Salelo. In case you're wondering, I'm Malaysian. I was born in University Hospital. I grew up in a little island next to Kedah called Penang. I was in Penang Free School, educated in Bristol University, as well as the US for my MBA. About 5 years ago, me and some friends decided to set up an artificial intelligence company with no customers. Within 9 months, we got a contract with the Malaysian National Operating Oil and Gas Company. And we did about 2 years of predictive maintenance. So I work with VROC. What are we? We are predictive artificial intelligence platform for remote monitoring. That sounds really complex, so I'm going to make it simpler for you as we go along during this presentation. Sorry, I didn't change in November to December. Now, I think we've got to talk about the elephant in the room. Any one of you have gone to fill up petrol, you know pretty much that the petrol price has come down. And you see versus a year ago, you open up the newspapers, Brent crude finally went up to about $48 a barrel. I think it was at $70 a barrel about 2 years ago. So the oil and gas industry is facing tremendous challenges as we speak. So the price of oil and gas is going up and down. And you'll find in the oil and gas industry, for the first time in however long it is, Petronas actually said they made a loss. And everyone everywhere is under pressure to cut down their operational expenditure. So this is the scenario that we're in at the moment. You all know there's COVID-19, otherwise I would be in Uni 10 giving this talk. Now you're all in your home. I don't know how many of you are still in your pajamas. Naman, you don't need to raise your hand and let me know. But I mean, we've had a very, very different change from March 2020. So the oil and gas industry needs to evolve to survive. And I just attended a conference in Indonesia. Actually, I logged off about a minute ago because Melinda told me we were going to start a bit later. So I was listening to the experts there, and they said digitalization used to be a nice to have. Use of AI and digitalization is no longer a nice to have; it's a must to have. Okay, so I'll go to the next slide. So in view of all this stuff happening in the oil and gas industry, digitalization and getting a predictive artificial intelligence is the best bet for the oil and gas industry to survive. Okay, VROC AI, who are we? Okay, 5 years ago, no one had heard of VROC. I'd be very surprised if anyone had heard of VROC because I hadn't. Then after that, a friend of mine met me. We sat down over a cup of tea and he said, Juarez, I think you need to lead this company. So my job is to give presentations and sell. His job is to implement and do the project management. VROC started off in Western Australia. We were a pet project because everyone discovered there's so much data coming out of industrial equipment that no one can humanly look at the amount of data. So we are in Southeast Asia. I run the Southeast Asian operations. I run the Malaysian operations, Indonesia, Vietnam, as well as Thailand and Singapore. So why was VROC set up? Because big industrial equipment will churn out billions and billions of data points. Now, if I ask all of you guys to open up your Excel sheet now and please analyze 50 billion data points, none of you are going to say, yay, I really want to do that assignment. Now, the issue is that engineers need to analyze this data. So VROC was designed to help engineers look at all these billions of data points and create actionable insights. So we're looking at what are the insights that an engineer wants to get out of their equipment. So I'm just going to pause here and open that up to the floor. What does an engineer want to learn when he looks at his data? Yin, since I talked to you yesterday, what's your opinion? What do you need to know as an engineer when you look at your equipment data?
The machine learning skill.
Machine learning skill. I don't quite understand. What do you mean machine learning skill? What do you need when you analyze all the billions of your data points? What's the 1 or 2 or 3 things you need to learn from your machine?
First one is the data that we obtain from the machine.
Okay.
Then we visualize it.
Okay.
Then we analyze. It's the last step.
Okay, I like that. I don't care about the data from the machine because it's all binary code telling me when the switch is on and off, micro milliseconds. That all I don't really care about if I'm a maintenance engineer. Correct? What do I need to learn from the data? What's the output of my analytics that I need to have? Keng Jun, what do I need to know as a maintenance engineer?
Okay, for my opinion, that all the data is used for just solving the problem.
What problem?
Engineering problem. Yeah, from the data depend.
Well, put your thought what engineering problem is, my friend. I don't understand what engineering problem is. Give me an example of an engineering problem.
example, okay, if a boiler, then we obtain the data from the boiler, right? Then we can know that what the boiler condition and then all the situation of the boiler. Then if the boiler got problem or other things, then we can solve it by using that data. I mean, easier
Okay,
to see some.
excellent. I like that, Peng Jun. Now, the end thing that engineers need, the engineers don't really need the data. They don't need to know what the data looks like because sometimes the data is binary, on-off switches, on-off of valve, number of milliseconds of valve. All that data is very difficult to understand and comprehend. Thank you very much, Peng Jun and Yin and Melinda for letting me bully you. But the key thing we need to know is when the equipment will fail before it fails. So the key thing we need to find out is when will your boiler fail? When will your compressor fail? When will your turbine fail? Or when will your process fail? So we need to know that before it fails. And that's what VROC predicts. After I predict when it will fail, what else do I need to know? Anyone? That's a question, by the way. I was asked to make this very interactive. So, Pardip, what do you think?
I think it's really when and how the machine will fail.
Okay, when the machine fails is important. What else? How? Are you sure it's how, Pardip?
Maybe.
Okay, Izzuddin, do you agree with him? Do you think it's how the machine will fail?
I think it's the cost, sir.
The costs, okay, I can see that, but all right, I'll be honest with you. It's not all that. It is when it will fail, and it is also why it will fail. So I want to know that my compressor is failing. Why is my compressor failing? It might be due to the oil filter. So those are the key things I need to know. As a maintenance engineer, those are the things I need to know. When it will fail and why it will fail, not how it will fail. How it will fail by blowing up and putting mercury all over the place, I don't really care. I need to know when and how. Therefore, I can take corrective action before it fails. Because in engineering, especially in maintenance engineering, the first way that we do maintenance is number one, reactive. So my car breaks down, then I call the mechanic. That's very, very bad. If you're doing power generation, it means people don't have electricity. Number two, I will do schedule maintenance. Number three, I will do predictive. Number four, I will do prescriptive. So where VROC is we are in between prescriptive and predictive. That's where we are. So by telling you when it will fail and why it will fail, we move on to prescriptive. Now, any one of you know what the downtime in COVID-19 is like? What does that mean for you? It means you guys are all on Zoom or Teams or calls, and you all have really chunky webcams and lighting and stuff to do with the webcams. So when you look at downtime in COVID-19, what does it mean for oil and gas? Or what do you guys think it means? Anyone want to speak? Okay. Zuleika, unmute your camera. Unmute your thing. No, your camera's okay. It's fine. No. Zuleika, you're doing your, okay, you're not there.
Oh,
okay.
I'm not sure.
You're not sure? Okay.
Yep.
All right. Now I'm going to share this again and tell you. The main thing that we have in COVID-19 is that unplanned downtime takes a lot longer to repair. Why? Before anything goes wrong with my GE turbine, what I do, I call the guy in Houston. I ask him, hey, come over to Malaysia. And the guy says, okay, I'll take the next flight. Now I got flight or not? Not so many flights. And the guy got to spend 14 days in quarantine. Let me give you guys a real life story about downtime in COVID-19. I was talking to an engineer and the guy said, I got to send someone to off the coast of Sabah. Guess how long the engineer is going to be in the platform for 3 days. Guess how long the engineer has to spend in quarantine? Calvin?
2 weeks, sir.
2 weeks. Calvin, you're wrong. You're right first. When he goes from KL to Sabah, this is about 2 weeks ago, right? He told me he has to land in Sabah. Once he lands from KLIA to Sabah, he hangs out in Sabah for 2 weeks in the hotel. After that, he goes offshore. Then when he comes back from offshore and goes back to KK, guess what he has to do, Calvin?
Another
2 weeks. Well done.
1 month.
No, Tanje, wait. Belum habis lagi, brother. After that, when he goes from KK to KL, guess what has to happen? Another 2 weeks. 42 days to spend 3 days on the platform. So, ladies and gentlemen, downtime in COVID-19 is very, 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 in Chinese, we call it mafan, menyusahkan, and also very expensive because you cannot move people around so easily. Now, if you want to move a part from Houston to KL, it is more expensive. It is normally 3 times more expensive. So one thing that we've learned, all of you, I just want a quick show of hands over here. How many of you were using Microsoft Teams before March 2020? Please put up your hand. How many of you were using? Okay, Tenesh. Okay, I can see. What we have a few of you who are using Microsoft Teams, but I don't see a lot. How many of you now log into Microsoft Teams every day? Raise your hand. I think every one of you log into Microsoft Teams every day. So the key lesson that I want to just share with you, ladies and gentlemen, is downtime in COVID-19 means it's very, very, very expensive, and digital prediction or digital optimization or using AI is no longer nice to have. It becomes a must-have. That's where big data comes in. Yin, you talked to me about data. We've got to look at the data. That's a brilliant story that we have. Okay, one of those container cranes, this is a picture of the cranes in Singapore where VROC does maintenance work on. So we predict when the cranes will go down. Each one of those cranes has 2,500 sensors already built in, and it generates 4 billion data points a year. So if I say, Yin, please analyze the last 10 years worth of data for one crane. Yin, do you want to key in 40 billion data points into your Excel sheet? And if I say, Yin, I want you to look at 100 cranes for the last 10 years. That's 400 billion data points, or 4 trillion data points. How many of you want to process that on your Excel sheet? Raise your hand. Okay, good. I don't see any hands raised. It's called big data, in case you were wondering, because there's so much of it. And oil and gas platforms will generate about 50 billion data points. Depending on the size of your power plants, you could easily get 20 to 30 billion data points a year generated. So the way to analyze them has to be using AI and computing power. Now, the main difference is the AI and computing power in the last few years has gotten a lot cheaper. Most of you, if you're 20 years old, when you were born, your computers were really, really big. Supercomputers were taking a lot of room. Currently, the MacBook Pro that I'm using is probably more powerful than a lot of supercomputers 30 years ago. So when you look at traditional analytics and what's out there, I'm going to give you this example with your car dashboard. Most of the system is condition monitoring. So condition monitoring is like your car dashboard. So we look at your car dashboard and see if a red light comes on. Okay, we need to check oil. But what's the limitation with a car dashboard? Just asking this question out to, let's see, Tenesh. What's the limitation? If I just give you a red light and say, check oil, is that good for you as an engineer if you're managing a compressor?
It's not good, sir, because it's more like a reactive maintenance. Because it fails, then only you go and replace it.
Okay, but there's a light. It says warning light. Check engine oil.
Yeah, it's not good, it's bad.
It's good because at least you know the engine oil is probably gonna go out, right? But Tanesh, the big question that I want to ask you is, when do you change the engine oil?
And the light blinks.
When the light blinks. But you know, sometimes when you drive your car, the light blinks, you know. You can drive for 1 hour, 1 day, 1 month, 1 week. You might even be able to drive for a whole year, correct?
Yes.
So the thing missing with condition-based monitoring systems is they don't tell you exactly when it will fail, correct?
Yep.
And that is the bit where VROC comes in, because VROC does time to failure prediction. So the biggest problem with condition monitoring, it gives you that little red blinking light, but it doesn't tell you how long you have before you act on it. Because when you go to the real world, you will discover a red light goes on and say check. You do not have time to check it as soon as the red light goes on. Okay, so the big problem about this is one problem with condition monitoring system. Generally, it doesn't have exact time to failure. The other thing that it does is sometimes it looks at the compressor or rotating equipment. Now, all of you guys are mechanical engineers, is that correct? Most of you are mechanical engineers, yes?
Yes.
Yes.
Yeah,
Correct.
okay. So when you look at the failure of the rotating equipment, I just want to see whether any of you can guess when you look at rotating equipment failure in an oil and gas platform, for example, rotating equipment is generally the turbine and the compressor, and that's where a lot of the equipment fails. How many % of the equipment fails due to rotating equipment itself, or due to process, operation, wells, or external factors? How many % is due to rotating equipment itself? When a compressor fails, how many % of the time does it fail because of the compressor itself? 60% of the compressor failure is a compressor itself, and 40% is due to process, operation, well, or external. Che Abdul Hadi, what do you think? Okay, let's see. Who's on my thing? Saiful, what do you think? Okay. Azrai, what are your thoughts? Wow, I'm not getting much of a response from you guys. You sure you're all not just like putting on mute and going off and doing your Facebook or Instagram?
So I think
Okay.
maybe because of external factors, is it?
Okay. How many %, Tanesh? Give me a guess.
I think around 70.
Okay. Pretty close. Peng Jun,
Yes.
how many %?
65, sir.
65. Okay. Malinda,
I'm not sure, sir.
give me a number, Malinda.
60.
60. I had discussions with the engineers in Petronas, and they gave me 95% of the failure happens due to something happening outside of the compressor or turbine. So that's actually quite a large number. So the big problem with condition monitoring software is they tend to only monitor that piece of equipment and not whatever's going around outside. Now that's very important, because when we did work with the cranes in Singapore, we found out that there are 300 cranes we were monitoring. 5 cranes were failing faster. The load bearing was failing prematurely. And then we looked at the AI and we analyzed everything. And we found out that the wind speed was fast. And then when we found out the wind speed was fast, it's only for 5 cranes, because they were at the end of a wind tunnel effect. If you go down Jalan Tun Razak on a windy day in Kuala Lumpur, you'll find the wind blows faster, because they're very, very tall buildings and there's a wind tunnel effect. In Singapore, there are tall buildings and they're at the end of a wind tunnel. So if you only analyze the things around the load bearing and not the external factors like the wind speed, you can miss out some of the reasons for the failure. So what do we do in VROC AI? Let me tell you what we do for a living. I think Yin, you're right. We take all the data. So we take the data, whether it's your wind data, your water data, your wave height data, your wind speed, all that data, your process data, your operations data, your binary data. So whether you're valve goes on and off, the number of milliseconds or microseconds for your valve to go on and off, semua kita ambil, kita pop kaliau. We take everything kasih masuk into our AI. And then what does our AI split up? We tell you when your critical equipment will fail before it happens. The nickname that we got for one of our clients is BOMO. I hope all of you understand BOMO. If you don't understand BOMO, raise your hands. By the way, ladies and gentlemen, this is an interactive thing. I'm a very, very casual sort of guy. I might be older than you, but please don't call me sir. Just raise your hand if you have any questions along the way. Feel free to raise your hand. I'm okay to take it. So what does VROC do? We take all the data and then we give you time to failure and root cause analysis as to why the failure in the future is going to happen. Now, what does this mean? A lot of times people have a compressor monitoring software, process monitoring software. Semua tu tak payah. We have one software to rule them all. So there's one single software license. We take the data from everything, Pi Historian or wherever else. Now, the other thing is your manufacturer. In general, your manufacturer will be someone who wants to make money off the spare parts. If any of you use a Gillette razor, you will spend 40 ringgit on the Gillette razor. And then every year you will probably spend 200 ringgit on razor blades. So the maintenance contract for someone who sells you a GE turbine, the maintenance contract could be 70% of the company turnover. VROC isn't an OEM. So we are pure software provider. We are a platform or subscription as a service. We charge you an annual fee. And as a result, you'll get a software like an iCloud, except we're more high spec, high sophisticated software. Okay, any questions at this point? Please raise your hand and ask. If you have no questions, it means that I am giving an amazingly great job in my presentation because you faham kau ataupun you tak faham langsung. So I'll continue. Oh, good. Have we got a question?
Yeah.
Got a hand raised? Okay.
Is it where it's going to take all the external factors, right? So different equipments have different points that you have to take, right? So how the software actually knows that this data has to be sufficiently for this equipment? And when you mean by external factors, it means like every single day or every single minute, or how it works?
All right. So how does the AI know whether it's a compressor? Normally we classify the tags. The tags will all go into a historian. So they'll go into the Pi historian and have all the data from compressor and it'll be labeled compressor data. So normally when you open up the tag, it'll say gas compressor mode GCM300 pressure, flow, or temperature. So the tag will be labeled by the manufacturer. One question people ask me, how does VROC take data from a solar compressor or GE turbine? Actually, one of the things I learned being in the car industry was that the Bosch diagnostic or the Siemens diagnostic machine, when the Germans told me this is specifically designed for the BMW, it's actually not true. It can work for Perdua or any piece of equipment. When you look at oil and gas, it can work on any piece of equipment as well because all the values are able to be sent out via CSV, comma separated values. So Tanesh, I think your question is also, what does the AI look at? The AI looks at correlation. So when this failure is happening, what else is happening around the whole asset infrastructure? So maybe there's another switch going on, or maybe you, I give the simplest example from my colleague Egg Leong, who's in electrical engineering. Maybe you're in the big building called KLCC, and then someone on level 44 switches on the toaster, and the whole circuit blows. Now, the AI will be able to immediately say it's a toaster, this plug on this floor, this pantry, boom. Whereas if you're doing normal ways, you'd have to go and switch on everything, click, click, click manually all the way through 48, 49 floors. Does that answer your question, Tanesh?
Yes. So I believe it's more like a reverse engineering process, right? Is something like that? Or the process?
Yeah, we learn from past failure. So we'll take the last 2 years worth of data and then we'll process it and then work out when the failure will happen in the future.
Thank you.
So it's like a child. It's like my daughter learning when she touches a cup. If it's a hot cup, she'll go, ouch, and then don't touch this cup anymore because the water in there is probably hot. Or she'll see steam coming out, therefore the water is hot. So it's like you learn. Before, when you were a baby, you didn't know when hot water comes out, when steam comes out, it's hot water. Yeah. Okay. So next bunch of slides. Great question, Tanesh. So I'm done here. Now, how does it work, Ganesh? This is what it looks like. We work with all the existing sensors or data historians. We take data from everything, and binary data is included. So it might be your sensor data, the on-off switches, valve opening, valve closing, and all that will be taken into our AI. That will be sent to the cloud via a secure file transfer protocol. And we have a private and public cloud. Our cloud is designed with high-tech, high-spec equipment, which is normally a high-powered servers. So the servers would process all this data, and your on-site and off-site guys would get a dashboard. Malini, do alert me if any hands go up, because I can't see it when I'm on presenter view. So the end product you get is this really cool dashboard, which you can access anywhere where you are around the world. So prior to COVID-19, I could say if an engineer called Tenesh is sitting on a beach in Bali, sipping his Mai Tai or Toddy on the beach, flipping open his phone, he can call the guy in the TNB power station in Lumut and tell him, please, or Manjong, please open this and check, because this generator is going to fail in 7 days unless you change the oil filter. Right now with COVID-19, I can't use that example. I can say if engineer Tenesh is at home with his 3 kids and wife screaming at him, he can then call the engineer in Manjong power plant and say, change the oil filter on the generator, because otherwise it will fail in 7 days. So we allow this to be presented in real time. Again, there's no real such thing as data in real time, because after I send the data to you 1 second later, it's no longer real time. But we do take data out from the process. It depends with the client. Sometimes it's every second, sometimes it's every 15 minutes, sometimes it's every a half an hour, sometimes it's once a day. We don't need to take it so often because the processes are normally quite stable. So you won't need to take it too often. If you need to take data every second, you're telling me your process is very, very unstable. So this, ladies and gentlemen, is an example of the VROC analytical engine. This is one particular graph which shows time to failure. So in that time to failure,
Hello, sir. You are being muted.
sorry, I'm muted. Sorry, I meant to shut my camera off. Okay, can you guys hear me now?
Yep, we can hear you.
Yep, okay. So here, 14 days failure, half a day failure. Here, the same piece of equipment failed again 7 days later, and here it failed 4 days later. So we weren't given this data, but we would just stream the data. The data was just streamed to us. So this is the example of the accuracy of the VROC prediction in the orange line. So if you see the first round, we got it sort of not quite correct, 13.5 days. But after that, the AI engine was pretty spot on. Now, the good news about the VROC AI is we're not looking at human beings. So we're not trying to predict the mood of your husband, wife, boyfriend, girlfriend, housemate, or whatever, because human beings have emotions and they're very, very difficult to predict. But machines are not. They just have data on off switches. So machines are a lot easier to predict. So this is what happens with a VROC AI. We'll tell you when it will fail. Over here, it said it'll fail in a few days, so there's time to failure up there. We'll list out the top 20 failures responsible for the next predicted failure. And if you look, that little bar chart over there shows the weightage. So this is more likely. The model accuracy says we're 88% confidence. Anything above 60%, we're good to go. And it says the historical prediction versus actual, which is the other graph that I showed you. So this is the data which is shown to the engineer in real time on a dashboard. Okay, now you probably want to know where it worked before. This is a Society of Petroleum Engineers. So if we look at this over here, we have a constant tripping of a gas compressor motor was tripping regularly. So what we were able to do was to work out when it was tripping and find out how to prevent it. Because this compressor was tripping every 24 to 48 hours. The longest time it ran without trip was for 14 days. Now, if you look over here, you will see the before is the number of times the compressor tripped, and then after, only once, after applying VROC AI. Okay. All right. So what do you do with what's the end outcome after you put VROC AI? Your production goes up, your life cycle goes up, asset reliability and life cycle goes up, your safety goes up, environmental performance goes up, and you're a lot faster at making decisions because you know what to do. As a result, profits increase. So this is an example of a slide from one of our clients. Said in 2 years, they've saved 100 million ringgit in cost avoidance. Guys, I've got to pause for a second. It's telling me the network's not good. So I'm just moving on. I should be back in now. Okay, I'm back in now. Any questions for the moment, guys? No? Okay, no questions means you guys understand everything totally. So let's go on to the next. Oh, Tanesh, you have a question. Good, excellent. Question, please,
So,
Tanesh.
all right. So basically, what I understand so far is the VROC has a big chunk of historical data, and then it tries to find the normal behavior. And in the current events, if anything irregularities happens between the data, then it indicates that as a failure. Is it?
No, it actually tells you when it will fail. It doesn't just tell you, look, your heart is beating too fast, you might die. It will say you will have a heart attack in 7.2 days by, yeah. So it actually gives you the exact time for failure. It doesn't say, look, your oil pressure is too high or whatever else. It can actually predict your oil pressure will go high in the next 48 hours or something like that.
Yeah, that's the part I don't get. I mean, like how it knows exactly the time point, the duration.
Okay, it takes the data in and it works on historical data. So working on historical data, it then learns. Now, you probably have, I mean, the simple example, you have a range finder on your car or your vehicle, correct? If you have a range finder, it tells you have 578 kilometers left before you run out of petrol. Now, this 578 kilometers will go down to 300 kilometers if you've been driving very fast. If you drive very slowly and you don't accelerate and brake a lot, your petrol consumption from 578 kilometers might go up to 678 kilometer range. So it's like the range on your car. It's dynamic. If a wave hits a platform, your 7.2 days may then go down to 2 days. Good so far, Tanesh?
Yeah, thanks.
Okay. All right, good. Let's go back to our little PowerPoint. So this is a quote from one of the guys in Petronas. They were our first client here. So what do? We predict. We also help you optimize your setup, and we also do digital consulting if you want to know where to go, how to go about things. So that's what VROC does. The case study I just shared was a deck in the SPE. This is a savings that VROC achieved working with the team at Petronas. So compressor availability moved up from 60% to 100%. They saved 53,000 barrels in 4 months of using the AI. Flaring target compliance moved up from 50% to 100%. Compressor utilization moved up from 94% to 99.4%. Any hands raised? Raise hand. Melinda or Tanesh, let me know with any hands raised. This is a GCM3. The problem was.
Excuse me, sir. There's one.
Oh, we got a
from
question. Okay, Pardip, excellent. Question time.
I would just want to ask, so the VROC AI, you get data from the sensor or any measuring instrument, right, from the equipment? Or let's say the instrument or the measuring device is failed,
Yes.
how to be able to predict the exact time of failure?
Sorry, VROC takes data from all the sensors, yes?
Sensors
That is correct.
fail.
Yeah.
Let's say the
So,
sensors fail.
what we do is we can give you an alert as to when we stop getting the data from the sensor. I mean, we've got to understand artificial intelligence is only as good as how we predict it or program it. And I mean, screw ups do happen. I have a Garmin watch. And one day, in my not so smart days, I decided to ride 100. I cycled for 113 kilometers. Then my Garmin watch told me, move. You have not reached your step count goal. Now, I can tell you after cycling 113 kilometers, I really don't care about my step count goal. But it said you are not moving enough because your steps are not enough. So you've got to understand there are limitations with AI, but what we will do if your sensor doesn't give us data is we can program it to give us an alert.
Okay, sir.
Answers your question? Yep.
Yes.
Okay. Now, this is a case study that I mentioned, gas compressor Moto 3, solar compressor and an offshore platform churning out 16,000 barrels a day. Every time it tripped, they had to shut down for 24 hours. The longest time it ran without trip was 14 days. Now, when it ran for 14 days without trip, if it ran for about 5 days without trip, they would actually celebrate and have a mini kanduri. So after that, they will ask us, hey, Juarez, can you help us with GCM3? So we came in and did the analysis in 45 minutes, and we said two issues we identified: loop oil header pressure because they changed the oil filter from original to an OEM, and we said discharge pressure because GCM3 ran on manual setting instead of auto. And once these two issues were resolved, it ran for 4 months before any trips happened, and the savings there was over 20 million US dollars. So this is a dashboard that you see. We said these are the things that we identified. If you look at there, that's our time to failure. Now, if you look at traditional condition-based monitoring, your discharge pressure is still within the normal operating limits. It's not the ups and it's gone up and down, but it's still within normal operating limits. So you won't be able to predict when it fails. But if you look over here, the orange line is VROC predicting the actual time to failure before it happened. And over there, G is the reasons why it happened. And 79% confidence level is very high. So loop oil header pressure. And the other thing was analog process control. Any questions on this case study so far?
I don't really get what is stated in the graph for us. Can you explain in detail?
Which graph? The one on the right.
The one on the right.
One on the right is time to failure. So you look at the squiggly line, that's a prediction of the failure. Squiggly line is VROC's prediction of when it will fail. Discharge pressure is a bar on the top, which is showing the discharge pressure moving up and down. But if you look purely at discharge pressure, you don't know when it will fail because it's still within the upper and lower bandwidth. So if you look at condition monitoring, you'll only see it within the upper and lower bandwidth.
Yeah, now it makes sense.
Okay, good.
Okay.
Any other questions that we have? No? Moving on to the next case study. So this case study, Hellas, you can ask questions when I end after this on this case study. I'll move on to the next one. If you're all okay? Okay. All right. All right, there's an aluminum refinery, ladies and gentlemen. There was a problem in building 35. Now, when there's a problem in building 35, where do we put all our resources? There are 50 buildings in this installation. Dekat mana kita nak bagi tumpuan kita? Kalau masalah tu dekat building 35, bagilah tumpuan dekat mana? Anyone? Building 35. Ataupun do we have the time to look at all 50 buildings and analyze the data from 50 buildings? Generally, tak ada. Especially since maintenance engineers are busy. Tapi AI ni doesn't have those limitations. So kita ambil, we took a Western Digital hard drive, took all the data, masuk into our AI, and the AI said the problem is not in building 35. He said the problem is in building 25 is the rock crusher. So if the rock is not crushed to the correct size, then the rock goes through the process again. And if you look over here, you will be able to see that the caustic soda gets added before the rock is crushed. Then the rock goes to the correct size. If the rock is not being crushed to the correct size, it will go through the process 8 times. And therefore, caustic soda will be added 8 times. This caustic soda is causing the premature failure of the filter in building 35. So it goes all the way down to building 25. By the way, this problem was plaguing engineers. Lebih kurang 10 tahun. They had this problem for about 10 years. The engineers were unable to solve the root cause. And the VROC AI was able to do this in a matter of minutes. Another case, any questions on this case study so far? Nope. Okay, next. No questions. Next case study. Okay, so VROC predicted electricity trip due to a battery that needed changing. We said this battery needs changing. The offshore team overlooked it. They said, tak ada lah ni, battery ni hanya 6 bulan, won't fail. It did fail. And when it did trip, the platform had no electricity for 12 hours. We said it's going to fail in 24 hours. And exactly 24 hours and plus or minus 10 minutes, the platform failed. We also predicted a compressor failure. These are instances where sometimes we have engineers who say, I don't believe the AI. Saya tak percaya AI ni. And then they wait, and some of them aggressively wait and see, will it actually fail when it does? In one case, we predicted failure of a compressor and it tripped, and not only did it trip, but mercury went all over the place. If any of you do your health and safety modules, you will realize mercury is a very, very bad thing to have around. The compressor and platform was down for a couple of months as a result. Any questions on those two things? Otherwise, I'll go on to the next bit on process optimization using VROC. So here's an example of what we did. We avoided a one-day shutdown using process optimization. This is probably what you would do in a plant where you could use VROC to look at heat losses in a coal-fired plant, or you could look at seeing how to run the burners more efficiently, or when to maintain them. So this is an example of a slide presented by clients. So they said, why is the moisture content high? Now, the 96.8% degree of accuracy is very high. It's rare that the AI gets that amount. Now, they said, why is the moisture content high? The SOP on an offshore platform, after 2 days of high moisture content, kalau moisture tu tinggi untuk hari ketiga, maknanya kita kena tutup platform. They have to shut down the platform and top up the glycol. The word shut down in an oil and gas platform is a very bad word, because during those days at $70 a barrel, it cost them $1.1 million a day to shut down, which is a lot of money and can educate a lot of engineers at Uni10. So they said, why is the moisture content high? Now the AI is not so smart. When you top up the glycol, it put glycol is all the factors. Out of 20 factors that identified, 19 of them were glycol rated. Tapi satu tu was about PT244. PT244 is a tag for a well. So it said that this one HGOR, high gas oil ratio well, this one well is causing the high moisture content. So they shut down that one well and moisture went down. Therefore, they avoided a one-day shutdown, because in 30 minutes, it said, look, these are all the factors causing moisture content. And this is the factor that we need to look at. If there are no questions, I'll just share. This is what the dashboard looks like. Our dashboard is very different from others because it's a blank page. You can put whatever you want on the dashboard. So you want to put your compressors there, go ahead, put your compressors there. You want to put your generator. You want to look at process value prediction, oily water separator prediction, or water launcher prediction. All those values can be put in your dashboard. So there'll be one guy who looks at compressors who will develop his own dashboard. There'll be another guy who looks at the generator who has their own dashboard. The process guys, the well guys, semua tu will have their own dashboards that they look at. This is a later version of the dashboards, because I know engineers like dashboards, because I said, what do you do with all that data? What do you want? Immediately, all you guys said, we want dashboard. Okay, so dashboard over here is the well failure in an offshore platform. So we changed it. This won an award at Oil and Gas Asia 2019. So we had a well ranking, 69% chance of failure on day 1, 88% chance of failure in day 2, and 100% chance of failure in day 3. So we looked at 3 factors. One was flow, pressure, and temperature. So you could say the bulk of it is due to flow, pressure, and temperature, and you click on it, and another drop-down button will appear. So in summary, what does VROC do? We do time to failure in number of days. We do root cause analysis. We do the total asset. So we look at everything, external factors as well. So we give you a holistic view of your asset, and we give you that model confidence rating of 0 to 100%. But generally, anything above 60%, and you're good to go. There's one more slide that I have. I think I'm more or less still on my time frame with you guys. I'll share this with you now. This is something I'd like to talk to you about. By the way, any hands, Melinda, you gotta let me know if any hands have come up, so because I can't see it when I share screen. So let me know about that. So a lot of you, yeah, okay, good. And a lot of you ask me, are we all ready for digital transformation? Everyone is talking about it. You see every single seminar, cakap tentang digital transformation. Now, I work with a Malaysian national oil and gas company. They have nearly 300 platforms. Hooked up to the Pi server, lebih kurang, hooked up to the Pi server are only less than 10%. With accurate data, probably half of that. So the key thing is your system even hooked up to a Pi or a historian? Maknanya, if I tell you, Tenesh, get me the data from this TNB power plant. Oh, nak dapat data tu. Macam mana nak dapat? Sini, ambil thumb drive, jalan, pergi dekat situ, put on your safety boot, safety hat, put the thumb drive into the compressor, take the thumb drive out. So in many cases, not TNB. TNB is actually quite well hooked up. All the data in TNB goes back to Bangsa in the building that you'll see in TNB's HQ. The fifth floor has all of that, and it uses GE Smart Signal. So the data warehousing from all of TNB stuff goes back to Bangsa, and it's all connected by TNB's fiber optic private network. But a lot of other people, if you talk about Top Glove, I mean, all of you heard of Top Glove, right? There's a COVID case there. If you ask them, how do I get the data? They give you a thumb drive. They say, walk to the floor, take the thumb drive out. So this IoT, IR 4.0 is not a reality for a lot of companies. It is slowly getting there. But even when you look at people who say we are digital, sometimes you're lucky, kalau 70% to 80% of the data is there. Now, binary data is something that we need, the on-off for the switches, because then we can look at things and we can tell whether things are working or not. We need to know something that has occurred earlier, so then we can predict it, and there's a clearly defined problem statement. So if you ask me, please tell me why there's vibration, that's not worth your time, because vibration is a symptom. The biggest thing you want to do is to predict failure. When it vibrates excessively, then you know failure is coming. So that's not quite something you want. And then we need the engineers to quantify the cost. So the biggest problem that we have with the engineers we deal with is they say, I have a lot of problems, but I don't really know which one I want to do. And they predict, say, can you look at this? Can your AI look at this? I'm like, the problem's worth 10,000 ringgit a year. Why are we bothering with it? So those are things that we have to deal with when we meet the engineers out there. I hope my objective of giving you this talk is so you'll know a little bit about AI. Should you someday become a client of VROC AI or implement an AI, hopefully this will give you a better understanding of AI, what AI does, what AI can't do. For me also, yesterday when talking sorry guys, I got put in I managed to get kicked out of that inadvertently. My apologies for that. So the key thing over here is hopefully this would have given you an understanding of what AI is, what AI can and can't do. And right now I think it's open to questions from you guys. Any questions that you want on this? Please feel free to ask. If you're going to ask a question, may I ask that you put on your camera? Then at least I can see what you look like. Unless you're not wearing any clothes, then don't put your camera on. If you're wearing a sarong, that's okay. I could be wearing a sarong. You'll never know. Ladies and gentlemen, open to the floor. Presentation, Halas.
Good morning, sir. Can I ask a few questions? Okay.
Sure, Mr. Chua.
All right. In your number of years in working with the AI, what is the most challenging obstacles that you face when you want to tell people about this kind of AI, and then how do you overcome it?
Okay, I was told to be very candid when I'm doing this. Mr. Chua, what are you? Are you an electrical or mechanical engineer or lecturer?
I'm a lecturer in Unit 10 in the mechanical, but my background is aerospace engineering, control to be controller.
I mean, the biggest problem that I see, and I'm going to be blunt with you, it's the mindset.
Yeah, okay.
Okay, let me just highlight that, Mr. Chua, by giving you a few examples.
Yes.
Okay, so when they say, hey, this AI can predict it, the engineers, I like engineers. You all like to have hypotheses and test them, right? But you know, for God's sake, if the AI predicts it, it's going to fail in 7 days. Don't sit on your bottom and say, oh, let me wait to see whether it blows up. And then when it blows up and it splits mercury all over the place and your system's down for 2 months, don't come back to me and say, hey, your AI didn't predict it, because then I screenshotted it and sent it back to them. Then I got silent. I actually had to drive up and minta ampun to one guy who said, hey, your AI didn't predict. Then I pergi it. Still, AI predicted, tapi AI predict hari Jumaat. And the jokers don't work on Jumaat and Sabtu. So the fact that engineers, they feel threatened. Some of them feel threatened. And we have two groups of engineers. I think SPE, if you look at them, Chua, you got the younger guys. And the younger guys are younger than me. I'm 47. I'm already an ancient fart. But you look at the guys 35 and below, 40 and below, you're looking at 70% of the engineers are there. Then the other 30% are the old school guys who are still learning WhatsApp. And you know, before this, you ask them to do con call, they tell you go away. Now everyone's on con call. I got no choice. They have to learn Microsoft Teams. And the first time they do it, the camera is pointing to the ceiling. Yeah. So you've got those guys, the mindset of the guys, and the fear that AI will take your job.
Okay.
The mindset of, why do I need, you know, why do I want to put it? I'm scared of putting it in. And engineering mindset that I see, number one, you want to prove your hypothesis. So if it says it's going to fail in 7 days, okay lah, check lah, tengok kalau betul. Aku duduk sini tengok kalau betul ke tidak. So that's one problem that we have. The other thing is they want to distinguish their setup as being unique. My plant is special. Because one Indonesian engineer told me, Juarez, Indonesian oil and gas is very different from Malaysian oil and gas. And my background is I'm a lawyer and I'm an MBA holder. So but you know, I'm a closet geek and I love playing and talking things, but I'm not an engineer. So he said that to me. So I checked my partner, hey, Indonesian oil and gas really different. Then I said, which field? But Natuna field. Now, if you go look at your map, the Natuna field is off the coast of Kerteh. And there's a platform called Duyong, which feeds into the Medco energy platform. So they're next to each other. They're the same damn thing. If you tell me North Sea is different, okay lah, fine, I accept that, because North Sea is different climate, got freezing here, both freezing. Correct? Yeah. So the engineer's mindset into accepting something real, into wanting to accept it, acceptance, pushing it through, and then also understanding budgeting. Because if I tell a guy in oil and gas, okay, you need to pay for the screw and the compressor filter, 2 million US. Okay, done. I mean, not quite lah. But the spare part, okay, you need to pay to F-rate the guy. But you need to pay for a software which will tell you when it will fail.
Acceptance to the new tech lah, probably again.
Acceptance to new tech. But the good news is, in some ways, I was just on a con call earlier at a conference in Indonesia before coming to talk to you guys. And with COVID-19, I can do that. I was at the SKK Migas Forum, and Shah Harun from Petronas Upstream Digital was talking. And he said, there's an Instagram meme which was going around. What accelerated your transformation?
COVID-19.
Was it your lecturer from Uni 10? Was it your CEO, CIO, CDO, or COVID-19? It's COVID-19.
Yeah, COVID-19.
So they are moving, but the oil and gas, the way I look at it, oil and gas has tremendous potential. The good news is you save them 1 day of downtime on a 20,000 barrel a day platform, even at $40 a barrel. That's still 800,000 US dollars. That's a lot of money you can save. And a lot of the platforms, if you talk to MPM, have about 10% UPD.
Mm.
And no one even in Tenaga is running 99.5% uptime. We got to be realistic. No one is doing those numbers. Yet I see engineers, they tell me, Juarez, we are running 99.85% uptime, which I know is not true. They must be fudging their numbers somewhere.
Okay.
So I know there's a lot of potential to use digitalization to improve the performance. So the potential is there. And the business case in the power industry is very strong.
Mm. So the next question is, okay, as you mentioned, are we ready in your last slides? Okay, is our industries, whether I think those SMEs, are they ready for this kind of, in terms of the facilities, are they ready for this kind of applications, our SMEs?
Okay, I would not touch the SMEs.
Oh, okay.
Sell to them.
All right.
Because normally the SMEs are run by my dad's peeps, who are Chinamen. And we're very catchy up.
Okay.
Okay. So
Okay.
we won't spend money, we won't spend $1 unless we can get $10 back.
Okay, very Chinaman style, true. Okay.
SMEs now have been decimated. They've been wiped.
Totally wiped out by the COVID-19. Yeah, true.
Yeah, they've been hit hard. So, more budget. They don't have budget for this. So why bother wasting time digitalizing SMEs? Now, if I tell Tanesh, hey, Tanesh, your cousin brother with a banana leaf store, I think he should digitize. I tell you to. Okay, he'll put a GrabPay terminal and iPad. That's about it. No point doing other things. I want you to analyze exactly how many pieces of mutton varubal you sell. So what? I'm already making 1 million, 2 million ringgit a month. I really don't need digitalization. The lady selling nasi lemak, my char kway teow fella in Penang, Lorong Selamat, you think he wants to digitize? He'll tell you, go. I mean, the only thing he'll do is GrabPay. You guys are doing $1 million businesses a year. They're not going to digitize. Doesn't make sense. But are there areas where they can see improvement? If your plant is running very well, the most important thing you've got to say is, what is your business case for digitalizing? If you're already running well, your profitability is there, don't bother.
Okay.
Like, do I want to digitalize I'm in digital transformation, IoT. Have I got Alexa in my house? No, I don't need it. I don't need my light bulb to go on, off. It's just nice to have.
It's not must have lah.
Do you have that in your house, Mr. Chua? No. Well, yeah, you're teaching, you're talking about digitalization. You don't need it. It's not essential. But are there other things which I use? iCloud, Teams, Zoom? Yes. Because those are more essential for my life. Do I believe in upgrading my laptops regularly? Do I believe in speccing out my Mac with 32 gig of RAM? Yes. Maybe because I'm a geek lah. Where I put a 300 meg internet. I've got a 1 gigabyte line which I get 300 meg out of in this house. Do I do that? Yes, because that's why I want to pump my money. But do I need Alexa to switch on the light? No. So the key thing is make the business case for digitalization first, whichever industry you're in. Don't waste time just saying it's a good thing to have. The problem is your CEO goes for a conference, then he come back and he say, managers, we must digitalize. And the managers have no clue what to do.
Okay. All right. Okay. Thank you, sir.
Great question, sir. Tanesh, your hands up.
Yeah, Boris, what are your thoughts on digital transformation in agriculture?
Okay. I think, okay, I'm going to step back a little, Tanesh. If I was to give an advice to a 20-year-old now or someone around that age group, right now I would tell them, look into agriculture. Okay. Why would I tell them to look into agriculture? Hey, you got to eat lah. And if you go to the supermarket, you look, prices of imported goods are going up. And I'll tell you a little story if you don't mind, Tanesh. I'll elaborate. I got one of my very good friends who's from a very prominent atas Melayu family. Yeah. And he is a ex-CIMB banker. Right. And, you know, bankers, they don't go out the cup in the non-air conditioned area. He is now no longer a banker. And he now has about, I think, 10 acres of land in Kelantan, and he is a pineapple farmer. Yeah, and brother, he's not the mandor, you know. He is going there, planting the pineapple, learning how to get the pineapple seeds, and then putting them in. Because based on about 7 or 8 acres, his turnover could be over R1 million a year. Yeah, his expenses are, he's probably looking at a 70% gross profit margin. So if I were to relive my life over at the age of 20, I'll be a farmer, because there's a tremendous opportunity in farming. And he's doing the cheap pineapple, the 4 ringgit, 5 ringgit pineapple, not the 12 ringgit or 15 ringgit pineapples, because those will sell better and are easier to sell. That's the first bit, which wasn't a question you asked, but I hope you don't mind. I share that with you. Now, AI in agriculture. Okay, if you tell me we're going to use artificial intelligence to predict the weather, please don't. Because whatever apps you have are lousy at predicting the weather. I mean, they're only about 50% accurate. Because I play tennis. Every time my tennis guy, hey, check the weather, brother. Oh, it's going to rain at 3 o'clock. Okay, now we play 4 o'clock. 3 o'clock, dry. 4 o'clock, we get to court. 4:01, boom, the thunderstorm comes. So the use of AI in agriculture, I don't know what it would be used for per se, because agriculture is also a very finicky thing. Now, in the Felda guys tell me they were trying to predict the weather because they need to know when to put the fertilizer. Because if you put the fertilizer and a thunderstorm happens, boom, all the fertilizer is gone and your costs go up. So is it that you're looking at? If you're looking into agriculture like lobster farming, you have a wife, Tanesh, or a girlfriend?
Not really.
Not really. Not girlfriend or wife, or not really, or both?
Nothing.
Nothing, okay.
Engineer.
So, engineer. Oh yeah, okay. You find a girl. All my engineer friends say, if you find a girl in university, hold on to her because you're an engineer. Yeah. And yeah. Anyway.
No, sorry for interrupting.
Sorry. Can I just go on? Finish the last bit.
Oh yeah.
If you look into lobsters, now lobsters are very, very finicky, like girlfriends. They are very, very fragile. You get 1 or 2 degree temperature fluctuation, they die, and your whole crop is gone. So lobsters are very critical for that. Sorry. Okay. So I'd say, what are you looking to achieve using AI or digitalization for agriculture? And what objective do you want to achieve?
Like that's the point I don't really understand, because when you're talking about VROC, so we're talking about compressors and pumps, all these things that give out data points, right? Which is a binary value. But when you're looking at agriculture, right, where we are going to get these binary values? Like how we're going to collect the data? So that's the part I'm asking about.
I go back to exactly what I told Mr. Chua. What's your business case? What business problem are you trying to fix? Don't just look at digitalization. Hey, it's really cool. I'm going to digitalize my house. I'm not putting Alexa or Hey Siri to switch on my lights. I don't need it. I barely even use Hey Siri. Oh, shoot, something went on because I said Hey Siri. Okay, but I'm not even using it. So what problem are you looking to solve, Tanesh? Now, if you say we wanna put AI in maybe the pineapple canning plant, maybe that's something you want to do.
I didn't catch that. Could you try again?
Okay, sorry. Let me just switch off Siri. Siri, be quiet.
You can turn me off in.
Okay. All right. Yeah. So yeah, sorry. Siri is the uninvited guest there. So yeah, yes, finish. Further on to your question. Any other questions on that?
So for instance, right, okay, let's talk about VROC. Does VROC have engineers playing as an integral role in its operation?
We do have engineers. We do have software engineers, data scientists, and occasionally we'll get some people to look at the PNIDs. But back to what Chua said, Mr. Chua, my second challenge is data. because integrity of data is often not there. So,
Yes. I
yeah.
think in the Malaysian context, we have a lot of limitations of getting data. All the data are not available. A lot of situations, that's the thing.
No, we have data,
Yeah,
but
is
the
it?
fact is the data management is not very good. Let me give you the example of my Netflix account. My Netflix account told me my number 1 recommendation is SpongeBob SquarePants. My number 2 recommendation is Princess Diaries, and my number 3 is Love Actually. That is due
It's
to
a very good
Julia
mixture.
and Melissa. Julia is my daughter. Melissa is my wife. They didn't log off on my Netflix. They have their own Netflix account. I'm not, set up their own Netflix account, put their own icon there, but they didn't log off. Because they didn't log off, Netflix takes bad data and therefore comes up with these conclusions. So the integrity of data is very important. When I did, we did some checks on data in an offshore platform, and we found even though I'm not an engineer, I'm not as well educated as you, I found out that they came up with, what did they come up with? Oh yeah, a machine serial number gave me fluctuating values. And a machine serial number should be a static value. So I see a question there. Egg Leong, you have a question? Or something you want to add to that?
Yeah, so basically, I think essentially what Juarez and Mr. Chua mentioned, I mean, data is basically the blood of the organization. And there is no organization in the world that has good data. And it is imperative that any AI solution has to be robust enough to handle real-time situation. So I'm from VROC. I work with Juarez. Juarez is my boss. So just to add into what he has just mentioned, when you talk about data, typically in a sterile lab environment, we can get as much data as possible. But most of the time when we are in the field, there is no good data. I mean, data itself are supposedly, technically, you're supposed to keep for 5 to 7 years, but it's like a warehouse that nobody goes to. So I think it's imperative when we are designing AIs and any models or any predictive kind of methodology that the robustness needs to be built in. So the AI needs to be able to account for lack of data or data gaps or repetition. And that's why if you think back, I don't know, I mean, if you think back maybe 15 years ago when Yahoo and Google came out as search engine, they were not very good, right? When you key in something, they're not very good. I think that is the next point of where AI is going to go, where it is intelligent enough to decipher and distinguish between good and bad data or lack of data. So yeah, that's all. Thanks.
Thank you very much, Egg Leong. I could see some other hands. Pardip, you will put your hand up? Pardip, I think you have to unmute.
Sorry for that. When I was doing internship, I used to do 3D scanning and then designing and then do simulation, finally to complete the manufacturing. So I just wonder, in the future, maybe AI can predict any failure in the design, simulation, before we proceed with CNC machining? I mean, in the manufacturing industry.
Sorry, can you repeat the question, please?
When I was doing internship, I used to do 3D scanning, and based on 3D scanning, we have the scanning data, and we do reverse engineering. So we perform 3D design, and then we do 3D simulation before we proceed with CNC machining. So let's say if we have any flaws in the design or simulation, do you think in the future AI can predict or AI can perform any simulation by itself?
Egg Leong, you want to take that?
Yeah, so theoretically it should be, or it can be. In terms of simulations by itself, in fact, they are actually doing it now. So when you talk about modeling, right, it's basically simulation, right? What I think you're more interested in whether or not it's able to take all those designs and use fuzzy logic and to sort of look into it, because what you're talking about is not 1 and zeros. So just to give you an example, like what we're doing in VROC is that we're able to look into infrared heat signature files. So we can incorporate that into our modeling when we train the model, when we build the AI. So definitely there is no stopping, or it's not going to be a limitation. I think at the end of the day, it's just how you want to structure it, and how intelligent we can make the AI to become. Because at this stage, no matter what, right, we still need an input to the AI, because the AI can't just sit down and give you something, right? You still need to key in an input. And what we're trying to do in general in the AI world is trying to predict or to expect, to stay one step ahead, if you like, whether it's a consumer-based AI or whether it's like what we do on machine learning, on compressors and stuff, where we want to try to stay ahead, and basically the correlations between everything that we have given them, the AI needs to find the relationship between all those variables. So yeah, definitely it's something that can be done. It's just how do you want to structure it. Yeah.
Thank you for that.
Yeah, but we're not doing it. I mean, basically, we just do very simple ones.
Because I just wonder in the future, maybe AI can replace the complete engineering solution, design up.
No, not really. It will not be, because at the end of the day, any failure, someone needs to be held accountable. Basically, someone needs to be blamed lah. So if you imagine your whole entire design of an aircraft is done by the AI, then who do you blame when the aircraft comes down?
Yeah.
No, I mean, I'm just talking about facts, basically. Technically, yes, we can design everything. It's a very simple thing, right? For example, planes today, in actual fact, we can actually use the planes to use solar and static to power the plane, but we still use petrol. Why? Right? I mean, basically, it's a very simple thing, because life is at risk. So you know what? They need some insurance, basically. So yeah, when we come out as engineers, when we come out into the real world, then you realize that there's a lot of bureaucracy that actually prevents a lot of good solutions, simply because it's profit and loss, and agendas and whatever not. Yeah.
Thank you for that, sir.
Thank you.
Thank you.
Excuse me, sir. We have a message from the chat box from Dr. Mina saying that she has to leave.
Okay.
Yeah, she's the ALO of IMECI Student Chapter Unit 10.
Okay.
Yep. And
Thank
we
you
also
very
have a
much, Dr. Mina.
question from Muhammad Shami
Okay.
asking that, sir, does that mean AI only work on machine and not on living thing, as the nature of living is unpredictable?
I think we can do some stuff with human beings, but there are always times when we'll get it wrong. I mean, one of the common questions I get from the engineers is to predict the mood of their wife. And human beings have so many variables, and human beings have so many emotions. There are certain things we can predict, preferences for human beings, which you'll see in your Lazada app. When you buy certain things, it'll recommend, you buy a tennis racket, it'll recommend tennis balls and tennis grips. So that's very basic. Those things are doable, but sentiment analysis is not always that easy. That's why stock market predictions is not perfect, because that's based on how human beings feel. We can do some stuff with human beings, but we find for the moment with the current technology, predicting machines is a lot better, because machine data is fixed and does not have emotions which affect it. Egno, do you want to add anything else to that?
Yeah, when it comes to humans, I think there is a lot of solution out there predicting, for example, like what Juarez said, Amazon, Spotify, Netflix, and all that. I think there are certain aspects of a human. In fact, for example, there is an AI, I can't remember the name, but where it actually predicts whether the song will be a hit or not. And they do this prediction based on several factors, the harmonics of the music, and how it relates. So for example, there are certain songs that, when you listen to it for the first time, it really, you really get it, you're in sync with it, and, it really speaks to you. And so there are certain songs that, you don't want to hear it anymore. And so they actually analyze those, and those basically, again, translated to understanding how it actually harmonizes with how human interacts with music. So there are AIs that's actually being developed, and it's quite interesting because you know, it's going to be a very big business for, you know, labels and music records, because then they are able to predict whether it's going to be a hit even before they spend money on advertising or marketing. But then, of course, you know, the complexity is massive, because you're talking about human emotions and human age and you know, geographic location, background, and like rightly so. For example, like what Juarez talked about, even the prediction of a stock market has so many factors in it. So if you look at the stock market prediction, which is very much run by human, is that, you know, the typical consensus was that, you know, if NASDAQ rises or Dow Jones rises, the Asian market would rise when it opens, but it's never always the case. There's a lot of underlying factors that we haven't had, or we are not able to make correlations. And once that, if we can do that, then obviously, you know, it is quite possible. Yeah.
Okay.
We have a hand from Dinesh.
Yes,
Sorry,
sir.
all right. My question is like, first of all, I'm a mechanical engineer, final year student. So right now I'm in dilemma that I have much more interest in machine learning, deep learning, things like that, which has been my final year project. So as an engineer who's studying in engineering, and how you think that I can be prepared to enter the AI world or taking a job in something related to AI?
How do you be prepared? Well, I mean, general advice that I would give my younger self when I joined is do everything you can and get your job, do everything you can in that job, and learn everything. I mean, one of the skills I got as a lawyer was the ability to repair a photocopy machine because we were working until 2 a.m. in the morning. Yeah, so I can still tell you right now, if the photocopy machine doesn't work, I can shake the toner around and work it. You know, they say, what did your law practice do? And I worked in one of the top 5 law firms called Leahy Shamuddin. I say, what did you know, we were, it's probably one of the top 3 biggest in the country. And you know, what did you learn from your time in Leahy Shamuddin? I can repair a photocopy machine. Right? It says it's out of toner. It's not. You take the toner out, you shake it a little bit, you put it back in, and then it works. Yeah. So
yeah.
Advice to you is take a job, any job, and just do 100 and 200% more than what you're asked to do. And whatever you can involve yourself in, do. As a lawyer, I learned about various industries. So, and I learned about things from cocoa bean manufacturing because Nestle was my client, how to change the law in listing companies, all that various experience that comes in useful later on in life. Now, at your stage in life, if you want to go into, as a mechanical engineer, you want to go into AI, you might want to work in an AI company. That could be one thing. It could be working in a traditional company, but asking to be posted to the AI department or machine learning department, or working with vendors. So there could be many ways to skin a cat. But I think the most important thing that we can say for young people coming out there is keep the attitude to be open to doing any kind of work.
Yeah, just
yeah,
just to add to what Horace said. So my background is I'm an electrical engineer with a computer science many moons ago, and so I spent a lot of time working in semicon industry, and you know working in telecommunication, and now working on AI. And the joke that I always tell people is that the only thing that I ever got out of my electrical engineering degree was I only learned 2 things: Kirchhoff's law and Ohm's law. That's all I learned. And everything evolves around that, right? I mean, you guys will know. I mean, you know, electrical guys will know Kirchhoff's and Ohm's. But what I'm trying to say is that if you're interested in AI, I think stats is very important, right? And you can do AI, or you can do like predictions based on very simple, you know, Excel spreadsheets. And so it really depends, even for mechanical, if you're looking at structural integrity or even, you know, movements or talks or whatever industry that you're in, there are certain form of AI. It's, you know, it's not, AI is not something new. It's been around since the 1940s. It's basically statistics, except that now because computing power is so cheap, you know, and everything, it's like stats on steroids, basically, right? We're still using the same linear, non-linear regression, trying to figure out things anyway. When I used to work for telco before VROC, we use the Excel spreadsheet to predict phone calls, right? You know, whether this guy is calling the wife or calling the kids or a boyfriend and girlfriend talking. It's just very simple, right? If it's a phone call at 7 p.m. to 10 p.m. and then there's a 1 hour break, and then from 11 or 12 p.m. Midnight to 2, you can be sure that's a boyfriend and girlfriend calling. You know, if it's a 3 o'clock call, right, 3 to 3:15 or 3:45, and the call lasts than 30 seconds, it's a husband calling the wife or the wife calling the husband. Hey, remember to pick up milk. Remember, it's so based on, it's very simple. It's nothing. It's not rocket science, right? It's just very simple. So if you're interested in that, I would say, pick up books, read, and just explore, because it sounds very complicated and technical and all that stuff, but actually it's not. I mean, we as technical fellas, we like to put all these jargons in that sounds so, if you look at our engineering books, it's always 3 syllables on, 3 letters, short form synonyms, and that sounds like, wow, fantastic, but it's not. It's if you're passionate about it, there is a lot of industries that you can actually go into. And never be limited by what your background is anyway. If you look at Juarez, he's a lawyer by training, and now he's leading this AI company. It's like heaven and earth kind of difference.
Thank you.
Yeah, thanks.
Thanks for that, Ekyo.
No worries.
Any other questions? Wow. Okay, Malini, as you're the MC, do you want to do anything else, or?
We had a hand just now. I'm not sure. Ahmad Farouk.
Okay.
Yeah.
Good morning.
Good morning, Assalamualaikum.
Hello, I have a question about the AI. So, what is your opinion about the AI in the future? I mean, in the next 10 years in Malaysia.
Okay, the next 10 years of AI in Malaysia? Okay, is this a question saying, will Malaysia become a center for AI? Will it be overtaken by other people? Will there be AI, or will AI no longer exist? Sorry, which question is it exactly?
I think he's asking where we're heading as a country.
Where we're heading as a country? Still got the same government, right, as when we started at 10 a.m.? Okay, I think where we're heading as a country, I think it would, where we're heading as a country. When I graduated, we were a country in 1995 with a lot of potential. Looking at it now in 2020, I think the potential wasn't realized. I think there's a lot of things Malaysia can do to help AI companies and to work. I think the potential is there for Malaysia to become a digital AI hub. Now, the question is how we get all the infrastructure to support it. I think when they looked at MSC, MDEC, in the past, that was a good initiative. But we need to know what's next. Can we bring the private equity funding into Malaysia to get the valuations of the companies? Can we get the right people in there? What will the future predictions? It depends. I mean, part of it's government, part of it's private sector. Where Malaysia would be. Ideally, it would be great to see Malaysia as an AI hub, because we're both Malaysian. We'd like to see us give back to our country and hiring a lot more people, both in engineering qualifications as well in data science. But we never know. I mean, there could be so many roadblocks to that dream or vision. Yeah. Does that answer your question, Farrell?
Yes, sir.
I think that is all for the Q&A session.
Okay.
Do you want to add anything else, Mr. Horace?
Well, I just want to say one more thing. Maybe just one more piece of advice that I'd give. And I think question that we have to ask ourselves is what we want to do with our lives and what type of career you want. Do you want to be an entrepreneur or do you want to be a employee? And I think that's a very important thing that you may want to just put at the back of your mind and revisit. Because a lot of people say, I want to set up my own business. Setting up my own business is successful, it's glamorous, but it takes a certain personality type to do that. So that's just think about it long and hard, and that's always something to think about. And there have been many successful entrepreneurs, there have been many successful people in the corporate world as well. So it's a good thing to think about at this juncture of your career, just to put at the back of your mind and the back burner. But thank you very much for giving me your time. It's always invigorating talking to young people, looking at things in a different way. I feel a couple of years younger now, and Egg Yong and I are both the same age, although he looks younger than me. So thank you very much, ladies and gentlemen. Wishing you all the best and stay safe.
Yep. All right. Anything else from Mr. Ed Leong?
Oh, no. Thank you very much. I apologize for being late because I had something on. So yeah, thanks. Thank you, guys.
Yeah, it's okay. So we have come to the end of the session, and we would like to apologize if you have any questions or you don't get to answer anything. If you have any other inquiries or for more updates on our upcoming events, please follow our social media accounts. And we will also be posting a recording of this session on the iMackey Uniten YouTube channel in a few days. Thank you, Mr. Juarez Salilo, CEO of VROC South East Asia, for the great and inspirational talk today. And thank you, everyone, for attending today's talk. Before we officially end the session, we would like everyone to turn on your cameras for us to take a picture. Can we have more cameras on? I may keep comms. That is all, I think. It's okay. Okay. Thank you so much, Mr. Horace and Mr. Ekleong, for joining us and for your time today.
Thank you, guys. Stay safe. Cheers.
Stay
Bye.
safe. Take care.